is linked on the syllabus. Okay, so if you want to look at these later. All right, so what I am going to do is I am going to, let me zoom up so you can kind of see. I'm going to open Visio and I'm going to start talking about how you go about designing a database. And the reason I'm kind of starting on that today is just that it's going to take a while to cover that. And when we get going, it'd be good to have some like background, some beginnings for it. And again, we could spend and we'll spend a little more time on some of the process because it's really important that you actually go through that process when you're developing a database and that you don't do kind of like what we're going to do and do it off the top. So I am going to, with luck, Visio. So we do have Visio 2016. And I just typed VIS in here. We don't want Visual Studio, we want Visio. And with luck, it's licensed and will work. So I'm going to do Visio. Now I'm still in Zoom. And over here, what you have is you have a whole bunch of, I don't want to install any updates. So let's ask later. You have all these templates. And I'll show you which one we want to use in just a minute. I'm just looking. I'm not even sure that it is in the, there it is. We're going to be using the crow's foot database notation. Visio is a program that lets you do charts and design. It's actually a pretty neat program. You can design your office. You can do network design. You could do organizational charts. I mean, literally, it'll design. It has templates for almost any kind of design you can think of. What? You can get pretty complex. You can get Visio for free also. Same as the other things from DreamSpark or whatever they call it now, Imagine. And it's about $500 if you were to buy it. I mean, it's not like the hugely expensive, but $500 isn't cheap. It's free though if you get it off of the thing. It's, what would I say about it? As a design program, it's pretty good. There are, like, if you really, really wanted to do basic electrical design, you might want to get a program that does that specifically. If you really, really wanted to do some of these, you know, it does everything okay, but it doesn't specialize in anything. So it doesn't have the full range and complexity that some of the programs that specialize in one thing does. But I don't know of any other program that has quite so many, you know, design templates. And it does do some neat things. I don't see it here. There it has a wireframe diagram. There's a web page thing which will, you can start it and you can just click a button and it'll give it a website URL and it will go and map all the links to that website. You know, which is kind of neat. It tends to be more complicated than you can read, but that's a different thing. All right, so crow's foot notation. I assume all of you have it there. So I'm going to click on that. And crow's foot, I'll explain it too, is one of the more standard entity relation diagrams. There are others. There are other forms that you can get. But crow's foot is the one you're most likely to see. So I'm just going to do create. And I'm still in Zoom. I might stay in Zoom. So you should have, where are my shapes? That's a good question. Where are they?
Do we want it metric or US units?
Did I not get the crow's foot?
You didn't get that. Like, it didn't ask you that.
Yeah, and I think I may not have got. In terms of that, it doesn't matter because these are not measured.
Yeah.
New crow's foot. I swear I had that. Create. Where are my shapes? Stencils.
If you click on it, it asks you for more shapes, or about my shapes. Where it says more shapes there,
Yeah,
my shapes.
but I don't want favorites.
Oh, well, I tried.
Software and database, crowsfoot database notation. I wonder if that's a new thing in 2016 that you have to go get your stencils.
Mine popped up already.
Well, why didn't mine pop up? I feel left out. There's not a lot of things for this. There's entities, there's a primary key separator, there's a relationship, primary key attribute and attribute. I am going to, let me zoom down for a moment. I'm going to zoom my diagram as opposed to zooming. And I can zoom up here for a moment just to show you the thing. But I'm going to bring over an entity. This is just going to be the introduction. We're going to talk about what is an entity. And we'll talk about the kinds of relationships. And that might be it for today. So this is an entity. I'm going to zoom down now. Notice it has a name. Yours are blue. So you're under a different. I swear that he mustn't have re-imaged my machine. I think it's got things from last quarter.
Did you have Visio 10? 2010?
No, I think it's just that last quarter he didn't re-image the instructor machine. So a lot of my preferences when I change things are still there. Because this is fine. The reason I did this is that it's easier to read up here than the blue one that you have. But all of those are available under design. So you have all these different templates that you can use for color. I think mine is just this. But there are lots of, if you look at them, each one has its own. This is the one you got, right? I just went up to the menu to do design. Oh, you mean get this box on here? I just drug it over from the toolbar shapes. And they won't double click, you have to drag them. It seems like you should be able to double click it and have it show up on the graph, but it won't. You have to drag it over. Which is more readable for you guys? The what? This one? Oh, I didn't even see. It's all right.
Well, it's okay. I mean, it's 3 1/4, so we'll forget. If you're the right, I'll let you drink. But over here, no, you drink. Thanks.
All right. So when you have an entity, what it consists of is the name of the entity and then the attributes. Let's do one. I'm going to do it as department. So I'm going to double click up here and I'm just going to write department. Okay. That's the name of the entity. That's what the table name probably would be. All right. So department. And then I'm going to, I'm just going to do department ID. What that ID is, we could talk about that later. This is the PK here means primary key. What does the primary key mean much to you? What is a primary key?
Basically it's the social security number of that specific entity.
Yeah, it's a number or word that uniquely identifies it.
Typically, it's set up to just auto increment by 1.
You can increment by ones or whatever. You don't have to. I mean, it is possible that, like, departments probably have unique names or unique abbreviations. You could use that instead of a number. Typically, they just do auto numbers or something like that. But every entity should have a uniquely identifying field, something that is always unique, never repeats, and can't be left out. Because that's how you tie this to other tables, which is what we're going to look at next. Then the attributes are things that describe department. What would some of those be?
Name.
Yeah, so we have a department name. What other things could you think of that would describe the department? Phone, possibly? Yeah, so location would be, now when you run out of attributes, one of the things you can do is, I'm just doing an attribute and just drag out it. You might want those in separate fields. That's probably good enough for department. Does that make sense as an entity? They're not rocket science, but there are some basic things about entities. One is they should all be about one thing, right? You don't want to start combining things in an entity. You don't want to do department/employees. You don't want to do, I don't know, what else would you combine department with? You don't want to do combinations. So every entity should be about one thing only. And when we get into normalization, it gets a little dicey sometimes. What's one thing, right? And when should you split it out and say it's another thing? Things that often seem to belong together get split up in databases. So
Your naming conventions, you don't put spaces between the words. Is that required, or that's just a convention that you use?
I'm going to put a department here too. My naming convention is usually to put like the whole database table, the entity name in here. Trying to stretch that. There we go. Spaces are a bad idea.
Okay.
All right. Spaces are illegal characters, so it doesn't matter in the diagram. But when you get into the database of spaces, an illegal character in the name. Underscores are allowable, right? Actually, the only non-alphanumeric character is that you are allowed is a underscore. Yeah.
So you're starting each one with department.
I do that. That's a naming thing that I do. It's very verbose, right? You end up with really long.
Yeah. Does it make it easier later on?
It makes it easier to know what's going on, what's what table it's come from as you're joining things.
Just in case.
On the other hand, it's fairly typical. Another naming convention would be something more like
Yeah. Well, and for some of you, it makes sense, like name and phone number.
right.
And ID. It seems like it would kind of naturally happen with a lot of them.
Well, one of the reasons I do this, so I tend to use the whole word, but it doesn't. Department. That's actually
You are tired.
part. Well, I'm tired and I also don't type very well, even though I type a lot. I mean, I tend to just name it, but again, at the naming convention, typically when you go to work for somebody, they give you a naming convention too that you have to use. Some people would just do a quickie abbreviation underscore name. Underscores are very common in these too, rather than, I think it's because I program a lot that I do the camel case kind of. But you'll see a lot of that anyway, but spaces are a problem. The other thing that can be a problem, although at this point I wouldn't worry about it, is you don't want to use a reserved word. And that sounds easy enough to do until you realize that date is a reserved word. and section is a reserved word, and group is a reserved word. You know, so and these are reserved words in SQL Server and SQL. Okay, so there are ways around it when you actually build it. If you really wanted spaces, you can put them in square brackets, which says allow illegal characters, basically. But it makes it much more difficult to query and handle.
So if you had sale and then date as one of your columns.
You could have sale date as long as it wasn't just date.
Okay.
So the word date by itself is a reserved word because it's used to identify the data type, date. And it will let you do it, it's just that it causes issues.
Okay.
And in the design, it doesn't matter at all, except that I think it's a good idea to practice using the kinds of naming that you'll do it before. Naming conventions are important, and being consistent is important. And as I say that, I'll tell you that I am horribly inconsistent. I try. I do try, but I sometimes am not. I typically, instead of ID, typically name these with key. And I do it not because I would necessarily do this in production, but to be real clear to particularly you guys and the people reading it that this is a key field. ID is more common. Okay. So I'm going to do one other entity and then we'll start talking about relations. So I'm going to drag over another entity. And I'm going to call it employee. And I'll give the employee a key. We'd have to decide what that in key is. So if you auto number it, that auto number is probably not the same thing as the employee ID that they would be assigned at work, right?
You'd be surprised, actually.
Would you? So they would just give you the...
For example, when I worked at Capella University, my employee ID number was also the same ones that our students would get.
Well, yeah, so mine's, I get the same kind of
And that
ID.
it was still auto-generated. It was just auto-generated within that specific.
So here, the thing is with an auto number, so it's where I'm thinking of like it counts 1, 2, 3, 4, 5. That's different. Here, you might notice your student ID numbers look like Social Security numbers. The same number of digits and stuff. That's because if the database is set up to take your Social Security number. But the federal government said that that's a no-no. So, though they did it for decades. So what they did is, because it's not a relational database at the heart of this, it's a hierarchical database written in COBOL, and the fields are fixed, they just created a mask, a different number that maps to the same structure as a Social Security number. I've always wondered if they have an algorithm where they actually convert the Social Security number, but that would be a bit dangerous. I don't know if they do that. Because if somebody reversed engineered it, they could get to the Social Security number. Anyway, so this, when I say department key, employee key, I kind of content as to what that key actually is. If you were to do a Social Security number, I'm not going to do it in this one though, but you could have a separate key like it's 1, 2, 3, 4, 5, 6, and still put the Social Security number here, but just not have it as the primary key. I'm going to do employee, I'm going to do like last name. And first name, you could do middle if you wanted. I'm going to go get an attribute. You could put their address in here. Sometimes addresses are broken out into a separate table. We'll talk about that later. Particularly if you're doing shipping, they almost always are, because you could have multiple addresses that you have to deal with the shipping thing. What else do we want to know about employee? Maybe hire date. I'm not actually looking for completeness here because the point of these is going to be relationships in a minute. Anything else?
Wouldn't we also want to add the department key? So we know.
We
what
will. We
department-
will. That's where we're going. All right. So if you wanted to relate the department to the employee, anybody, you mentioned it basically.
Make it an attribute.
Yeah, so one of the things you can do is you could add employee key. What? Oh, not employee key, department key, thank you. I am tired. All right, so the department key here is to tie it to this, right? And if you want, I can show you in the data, but let's do a couple of other things to show the relationship. So one of the things I can do, and let me zoom that. Where is my zoom? Why is it not? There it is. So when I right click on this, come on. It has some options. One of them is set primary key, set foreign key. So I can change it to a foreign key. It puts an FK there. In a way, this is a little bit, it's good for design, but it's a little bit dangerous because when you get into the actual database software, none of them mark their foreign keys. So people expect to see that and you don't. The other thing is we want to create the actual relationship. And so over here, there's a relationship tool. And I'm going to drag it on here and I'll talk about it a little bit. And we'll talk about, this is what we're going to do now is the basic type of relationship. So before I do the connections, and the connections in Visio will drive you nuts because it doesn't connect the way it should. The three, this is the crow's foot. This is where it gets its name. Do crows have 3 toes? I guess they do. And what that means is this is the many side of a relationship. This is the one side of a relationship. We'll talk about the different kinds of relationships in a moment. I'm going to take the one side. The one side always points towards the primary key side, which is this one, right, with the department. So one department. So I'm going to just connect this. And what I want to do here is glue the shape. And when the whole shape has an outline of green, is your best bet. It's hooked now. You don't want to hook it to the actual key because it just makes a mess. And then over here, this is the mini side, right? The department, one department can have many employees. So this is the one side, this is the mini side. It shows you the relationship. It shows you there's a relationship here where basically one department has many employees. And the thing that's actually doing this, let me unzoom. The thing that's actually is required is the department key here and the department key over here. The only part about the department you need to repeat is this key. So every employee that's a member of that department will have that key. This is a kind of relationship that's called one to many. Good. %90 of your relationships in a database should be one to many, maybe all of them. All right. we'll talk a little bit about how you can, things that could come up with this. I'm going to add a second employee thing. Now, this is actually not a good idea, but it will illustrate the other, one of the other kinds of relationships. So I'm going to put it like down here. And I'm going to do, let's call it employee HR. I'm going to have the same key, employee key. Whoa. All right, so let's get rid of attribute name and then do employee key. And let's do like social security, employee, probably if I were following my own rules, employee.
Wouldn't it be employee HR social?
Yeah, it would be. You know what? Social. Ah, damn. You'd have to really figure out what the things would be here. Now, one of the things that does happen sometimes in real databases is that you will split a table into two. One, and this table is kept separate for security reasons, right? Because there's information here that you don't want to. You could secure this one higher than this one. It's actually a dumb way to do it, but it does happen, and it will give me a chance to show another kind of relationship. So I'm going to pull a relationship over, and this side will be 1. Come on, give me hook. Oh, I know why. I gotta get out of text. I gotta get my pointer tool back. There we go. And I'm gonna come down here, but it's not gonna be one to many. And the way that I change that, while this is selected, I'm gonna right click on it. Am I still zoomed? I think so. No. So I'm going to right click on this. And notice how it has show multiplicity. So I think I changed this into 1 and only 1. You can change the endings on these. So when I click on it, so set begin symbol 1 and only 1, set end symbol 1 and only 1. This is a kind of relationship. What would you guess the type of relationship is? 1-to-1, yes. So this is so 1-to-1 is a legal relationship in databases. 1-to-many is the standard normal relationship. 1-to-1 is a legal relationship, but it's very, very rare. Does that make sense? It doesn't occur very often, actually, but it is a legal relationship in the database. Questions? You look like you have questions.
No.
Typically, it's only used for special instances like this. It can also be used, I don't know if I want to go there though, for situations that kind of resemble inheritance. You might have an example that a database instructor I had once said. So imagine you had a boat table, and you wanted information about both motorboats and sailboats, but the information about each was quite different and they were exclusive, right? The stuff about sails doesn't apply to the motorboat. Most of the motorboat stuff doesn't apply to the sailboat. Questions on that one. But one of the things you could do is you could have a boat table, and then you could have a 1-to-1 relationship where every sailboat breaks out to a sailboat table. and every motorboat breaks out to a motorboat table on a one-to-one, but the main information, the one you query first, is here, right? So that's another kind of relationship where you could have one-to-one, but it is extremely rare. You could probably just almost forget it exists because you probably almost never use it.
So
It's
what,
almost always one-to-many.
so what would be an application for a many-to-many?
So the thing about many-to-many is that they are really common, but a relational database can't do them. So I'll show you what you have to do with a many-to-many. That's the next place we're going.
It's like the authors of the books.
Yeah, that's right. You have to create a linking table. Yeah. So let's create another entity, and this one is going to be called projects. And we'll give it a project key, whatever that is. And the project can have a name. And, well, project start date or whatever. Again, I'm not worried about completeness here. It's mostly just to show the thing. Now, let's say that every employee can be involved in many projects, right? There's more than one project. And every project can have more than one employee, right? So what that does is it creates a many-to-many. Each project can have many employees. Each employee can have many projects. It is possible to diagram that as a many-to-many. So I will do that real quickly. The only trouble with that is shoot, I didn't want to connect down there. Will it move? No, shoot. All right, so I'll zoom for this. I really hate the way that that Visio connects sometimes. I'm going to right click on that. Come on. Show multiplicity. Anyway, it's got the crow's feet on both sides. It's really ugly the way it's doing it there, but there's a crow's feet and there's a crow's feet. In a diagram, that's perfectly reasonable, but the fact is that there's no such thing as a relational database that can handle that. Okay? It can't resolve it logically. So you have to do a compromise thing. That would be many-to-many, right? Whenever in a relational database, now no SQL databases handle these all the time, but that's because they don't care how things match. Should I delete that? The way you handle it in a relational database, and if you remember nothing else, this, let me unzoom and kind of rearrange things here. That's another thing I don't like. These are all so big. Okay. And then one-to-one needs to move. Okay. So we're going to create a linking table, and I will call it, I don't actually ever name it this, but let's call it projects linking. And I am going to give it the project key. And I think I'm going to move this up above that, and I'm going to just give it also the employee key. And then I'm just going to delete that one. I'm going to make it another. We didn't talk about primary keys very much. What happens if I do this? Anybody know what that's called or what it's? I'm not expecting that. I'm just asking. So that's called a composite key. The thing is, no entity can have more than one key, but the key can consist of more than one column. So what this does is it says no employee can be assigned to the same project twice. That's basically what it says. You can assign many employees to the project, but no employee can be assigned twice to the same project. So it protects against that a little bit. It is also perfectly legal just to do a project's linking key and just make these foreign keys. But what the linking table does, so I'm going to get the relationships again. I'm going to do a 1 over here and the many up here. I'm going to get another one, and this one will be the 1 over here and many. Come on, give me the whole thing. Whoa, what did it? I don't like the way it did it. So it jumped down here, 1 many there, and then 1 many there. So basically what happens is that one project can link many times to this, to many employees. And one employee can link many times to this, so to many projects. It's a linking table that resolves the many-to-many relationship into 2 one-to-many relationships.
I'm still not clear as when you say that the database can't handle many-to-many, what do you mean can't handle?
It can't resolve it. If you tried to do a query on that, it would crash. It has no idea how to do that.
So I can't query, say, give me the name of the projects that Steve Conger is working on.
You can if you do this.
Only if you do it that way.
Yeah. And the thing is, when we get into doing the queries, as long as there's a path, I can get the last name, first name, project name. You know, you have to go through this table, but you can get anything down here. And in fact, you could get, if you wanted all the projects for a department, you could go project to project key to employee to department. You could do a query that would give you the department that's associated with every project, even though you're only doing it through the employee here. Does that make sense?
I'm gonna have to think through it, but if you set it up so that there's a many-to-many relationship, does the database alert you that you've set up
No,
a
it just
table?
won't work.
It just won't work.
Yeah.
Okay, so you have to spot that ahead of time.
Yes, you do. And that's actually one of the reasons why we really want to test things. One of the things that happens when you have a many-to-many relationship is that when you try to enter data, it won't work. It won't even let you enter the data because the relationship is such that you can't enter an employee until you've entered the project, but you can't enter the project until you've entered the employee. You know, it just gets into a mess. It gets into a loop. So just the way that computers work, it's not very good at resolving those kinds of things. But this always works. You can always create this linking table between this and this. You only need to do it when there's a multiple, when there's a many-to-many relationship. But you're right. The hard part is to recognize many-to-many relationships. It takes a while. And that's, it takes some practice. There could be a many-to-many here if any employee works in more than one department.
Now, typically, can't you, I mean, it's probably not fail-proof, but any table with multiple primary keys, is that not oftentimes a many-to-many, where there are going to be a lot of tables with multiple primary keys?
Well, so this only has one primary key, but it has 2 fields. No table has more than one primary
Oh,
key.
because those are,
It's a composite, right? No table ever has more than one primary key, but the primary key can consist of more than one column, than one attribute.
so project linking does not have 2 primary keys there?
No, it has one primary key that has 2 fields. If I were to make a child table for this, I'd have to repeat project key and employee key, both of them, because they're both part of the key. The idea of a composite key is that these are both part of the same key. They go together as a group always.
I see.
They're not separate keys. You should avoid these. In a linking table, it doesn't matter because in a linking table, you're never going to have a child table for this. But in general, you kind of want to avoid composite keys. composite keys come into practice a lot, and we'll talk more about keys, but they come into practice a lot if you're not doing auto numbers for your keys. So for instance, when you do a quarter here, if you weren't just numbering, so say you wanted to know a particular course. Every course has a, what do they call it? An ID number? It's not an ID number. What? Item, thank you. Item number, right? So maybe something like 3, 2, 1. The thing about that item number, again, this old ancient database, is that they're not unique. They're unique to the quarter, but they're not unique. They repeat the same item numbers over and over and over. Not in the same quarter, but across quarters. So you also need to know the quarter, right? So let's say winter. That doesn't work though, because winter last year would have the same item number as winter this year. So you also need to know the year. So when you have these three pieces of information, you can identify a unique course. So this would be, if you weren't just auto numbering things, this would be what you'd need to create a unique key for each quarter. You would need all three of these attributes to come up with a unique key. Where, as I said, where these come up a lot, and one reason why auto numbers are so popular for keys is it's really hard to come up with something that's unique all the time. If you're using, these are called natural keys. That means that they're built into the data naturally. They're not just adding an auto number or something. So these, when you're not using just auto numbers, you have to do some pretty elaborate things sometimes to come up with a unique key for a table. And as I said, it's one reason why auto numbers are so popular. There are drawbacks to auto numbers too. Though typically they're when you're trying to merge databases. Because you have auto numbers in both databases, you suddenly have massive key conflicts that you have to resolve. So one-to-many, and then I'm going to just real quickly write something here, and I'll post this on the blog, this picture, and then also we have the video. So what did I want? I want a text. I'm just going to say linking table. And I might move that up a little bit. So what question? I don't expect this to instantly sink in.
I'm just wondering what the project linking table actually looks like in a table form.
That's actually a really good question. So let's do, what do I want to use? This, let's do access real quick. So let's do blank database. Do you need this zoomed? I don't see it zoomed down there. So I'm going to go into design for a table. We'll call it department. We could just do employee project, I guess, right? You want to do all of them?
I just don't want to see the linking table.
Right. Well, so it makes more sense if we have, yeah, employee. We don't need department, but we need employees, I think. And I'm not going to put much in here. I'm going to put like employee name, employee email, whatever. An employee. All right. So real quickly, I'm going to go into, come on. Yes. All right. So those are probably auto numbers. Let's just do. I should have left out the email. So what that table is going to look like, essentially, is just numbers. Okay, so I'm going to do just two of them. So we got some data there, it's fairly stupid. So let's add another table. Create table, design, projects, and project ID. I'm just going to do project name. And I will go here, I will save, and I'm just going to put in project one, or project whatever, project one. Okay, so then we'll add one more table. Create table. I don't like Access, and I actually haven't used it in a long time. So I'll call this project linking. And so project ID and employee ID. And I don't want that to be, I want that to be number. Okay, so I made that a double primary key. Let's go to the data view. So say the project ID has both employees on it. So I'm going to do 1. And it's project 1, but I'm also going to do employee 2. Oops. And then I will do project 2, and we'll do just employee, I don't know, employee 2. That's what it's going to look like. So it's not going to be, in the end, it's not going to be humanly readable, right? It's just going to be numbers. It doesn't matter because the computer can resolve it. When you're writing a query in SQL, which we'll do eventually, the computer will look at that and it'll figure out which project goes with one and which employee goes with one, and it'll return information that actually makes sense to us. But this table is just going to be primary keys. Does that help? One of the things about databases in general, relational databases in particular, though, is that they are written for the computer. They are built on set theory and predicate logic, and they're designed for the computer to read. And the computer can resolve it. When we start talking about the SQL, we'll start talking about how you start to bring that information back together to make it humanly readable again, right? So, and then the next step to make it humanly readable is to create the forms and web pages and all of that. Most people don't deal directly with the database, right? They deal with the forms and the reports. No manager pretty much is going to want to write SQL when you get into the database itself. They just want to be able to click a button or type a couple of words and get the results back. But that's software. That's writing stuff in PHP or C# or Java. It's actually a different set of tasks. Access actually has forms and stuff in there. The other thing is, if we go into the relationships here real quickly, fields, database tools, relationships. I didn't actually make the relationships yet. They will work, but no, one thing I didn't do. I hate Access. All right, so and then project ID to project ID. You know, it gives you the same kind of relationships. One employee to many projects, one project to many employees. All right, any questions? I maybe should save that too, I don't know. This one I will post. And then, as I said, there's the video. Don't know how good it is, but it's there. Pretty sure it kept, yeah, it's still on sharing, which is good. Sometimes